Dear 10th class students, we are continuing mensuration in this session. In our previous video, we covered introduction of mensuration, formulas in mensuration, and also solved a few problems relating to areas. In this video, we learn to solve problems relating to volumes of solids. Without wasting of time, let us go into the question. Dear students, I again emphasize that formulas plays a vital role in the chapter. So, understand the formulas and by heart them. One more suggestion from me is read the question twice or thrice. Draw the rough sketch and then solve it by applying the formula. Let us solve the first question. An iron pillar consists of a cylindrical portion of 2.8 meter height and 20 centimeter in diameter and a cone of 42 centimeter height surrounding it. Find the weight of the pillar if 1 cubic centimeter of iron weighs 7.5 grams. Dear students, in this question we have two solids. One is a cylinder, another one is a cone. Now let us find the volume of the cylinder first. According to the problem, the diameter of the cylinder is 20 centimeters. So, radius is 10 centimeters. The height of the cylinder is 2.8 meters. 1 meter equals to 100 centimeters. So, 2.8 meters equals to 280 centimeters. The volume of the cylinder is pi r square h. That means 22 by 7 into r is 10. So 10 square into height is 280. By simplification, we get 88,000 centimeter cube. Now come to cone. The radius is the same, that is 10 centimeters. Height is given as 42 centimeters. From the formula, volume of the cone is 1/3 pi r square h. By simplification, we get 4400 centimeter cube. The total volume is 88,000 plus 4400, that is 92,400 centimeter cube. The weight of 1 centimeter cube iron is 7.5 grams. That means 75 by 10 grams. 1 gram is 1 by 1000 kg. So it is 75 by 10 into 1 by 1000 kgs. So weight of the pillar is 92,400 into 75 by 10 into 1 by 1000. By simplification, we get 693 kgs. Now, let us go to the next question. Find the volume of the largest right circular cone that can be cut out of a cube whose edge is 7 centimeters. In this question, the side of the cube A is 7. Here, the base of the cone is circle, touches the sides. So, its diameter is equals to side of the cube, that is A. So, radius is A by 2. A is given as 7. So, radius is 7 by 2 centimeters. Height of the cone is equals to side of the cube. So, h is equals to height is equals to 7 centimeters. So, Volume of the cone is the formula 1 by third pi r square h. By substitution and by simplification, we get 89.83 centimeter cube. Now let us go to the next question. The spherical marbles of diameter 1.4 centimeters are dropped into a cylindrical beaker of diameter 7 centimeters which contains some water. Find the number of marbles that should be dropped into the beaker so that the water level rises by 5.6 meters. In this question, we have two solids. One is cylinder and second one is spheres. Now, let us come to cylinder. The radius is diameter by 2. Diameter is given as 7 centimeters. Look here, diameter is given as 7 centimeters. So it is 7 by 2. The height of the cylinder is 5.6 centimeters. That means 56 by 10 centimeters. So the volume of the cylinder is pi r square h. By simplification, we get 56 by 10. Here, look here, pi into 7 by 2 into 7 by 2 into 56 by 10 centimeter cube. Don't simplify it, keep it aside. Now come to sphere. The radius of the sphere is d by 2 is equal to 1.4 by 2, that is 0.7, that is 7 by 10 centimeters. So volume of the marble is, because it is in the shape of a sphere, it is 4 by third pi r cube. So 4 by third pi into r is 7 by 10. So 7 by 10 into 7 by 10 into 7 by 10. Now, number of marbles dropped in the cylinder is volume of the cylinder by volume of the sphere. By simplification, we get 150 spheres or 150 marbles. Now let us come to the next question. A metallic sphere of radius 4.2 centimeters is melted and recast into the shape of a cylinder of radius 6 centimeters. Find the height of the cylinder. Here, two solids are given. One is sphere, another one is cylinder. Because it is melted and recast, their volumes are same. The radius of the sphere is 4.2 centimeters. That means 42 by 10 centimeters. Volume is 4 third pi r cube. So 4 by 3 into pi into 42 by 10 into 42 by 10 into 42 by 10. Now the radius of the cylinder is 6 centimeters. Height is not known. We have to find the height. Now the volume of the cylinder, the formula says pi r square h. So pi into 6 into 6 into h. We already told you the volumes are equal. So by equating the volumes and by simplification, we get the height of the cylinder, that is 2.74 centimeters. Now let us come to the next question. A well of diameter 14 meters is dug 15 meters deep. The earth taken out of it has been spread evenly all around it in the shape of a circular ring with width 7 meters to form an embankment. Find the height of the embankment. Now we know that the shape of the well is a cylinder. So radius of the cylinder is d by 2, that is 14 by 2, that is 7 centimeters. Depth is 15 meters. So volume of the earth taken out from the well is volume of the cylinder, that is pi r square h. So pi into 7 into 7 into 15, that cubic meters. Keep it as aside, don't simplify it. Now come to ring. Observe the figure carefully, and it is the ring. In the question, it is given as 14. So its radius is 7 and width of the ring is given as 7. So big R is 7 plus 7. 7 plus 7. So big R is 14 and small r is 7. Here it is given big R is 14 and small r is 7. Area of the ring, according to the formula, pi into big R plus small r into big R minus small r. So pi into big R is 14, small r is 7. 14 plus 7 is 21 and 14 minus 7 is 7. So volume of the earth according to the embankment is area of the ring into height. Area of the ring is given as pi into 21 into 7 into height h. Hence volume of the earth is pi into 21 into 7 into height equals to pi into 7 into 7 into 15. By simplification, we get height is 5 meters. So height of the embankment is 5 meters. Let us go to the next question. A container shaped like a right circular cylinder having diameter 12 centimeters and height 15 centimeters is full of ice cream. The ice cream is to be filled into cones of height 12 centimeters and diameter 6 centimeters. Find having a hemispherical shape on the top. Hemispherical shape on the top. Find the number of such cones which can be filled with ice cream. This is the container. From this container, we are preparing ice cream cones. So, their volumes are equal. Now, let us go to the question. The container is in the shape of cylinder. Its radius is d by 2, is 12 by 2, that is 6 centimeters. Height is given as 15 centimeters. So, volume is pi r square h, the formula of cylinder. So, by simplification, we get 540 pi centimeter cube. Now come to cone. Here we have two solids. One is cone, another one is hemisphere. One is cone, another one is hemisphere. First find out the volume of cone. The radius is d by 2 is 6 by 2 is equal to 3 centimeters and height of the cone is 12 centimeters. So pi is equal to 1 by 3 pi r square h according to the formula of volume of the cone. By substitution we get 36 pi centimeter cube. Now come to hemisphere. The radius is 3. So its volume is, the formula for hemisphere is 2/3 pi r cube. So 2 by 3 into pi into 3 into 3 into 3, that is 18 pi. So volume of ice cream cone 36 pi plus 18 pi, that is 54 pi. Number of cones. The number of cones are volume of cylinder by volume of cone. Volume of cylinder is 540 pi. It is 54 pi. By simplification, we get 10. So number of ice cream cones can be formed are 10. Now let us go to small bits. The horizontal cross section of a cylinder. The horizontal cross section of a cylinder is circle. Similarly, the vertical cross section of a cylinder is rectangle. Similarly, the horizontal cross section of a cone, horizontal cross section, is circle, and the vertical cross section of a cone is triangle. Thank you very much. Dear students, practice, practice and practice. Practice makes man perfect. If you have any doubts or if you want any clarification, you can call me. And in the description box, we gave the link for notes and for part 1 video of mensuration. Thank you once again.